All right, so I think we can start. Welcome everybody to the Smap3D plant design webinar, jointly organized by PC Schematic and CAD Partner, which is the makers of Smap3D. PC Schematic and us, CAD Partner, we are working together for nearly 10 years now. The reason is actually that the PC Schematics provides the basic for our P&ID tool as a so-called OEM product. So if you're working with the PC Schematic, I trust most of you do, I think you will directly see the similarity between the PC Schematic Automation and our Smap3D P&ID tool. First of all, so that you know who's going to talk to you in the next hour, my name is Tim Free. I'm the sales manager of CAD Partner, responsible for the sales in Europe for Smap3D. And with me, responsible for the technical presentation later on, is Michael Mooney, who is our technical director in the US. I'm going to start with a short overview about our company, CAD Partner. Then I will go to the software itself, give you some more details about the single modules, and in the end, give you some details about some references, and then Michael will take over. So CAD Partner was founded in 1989, and we are recommended by SolidWorks and Solid Edge, the two CAD systems that we support with our add-in. So both also have their own solution for piping, but it's like a really simple solution. So if it comes to more complex piping or real plant design, this is something where they also recommend Smap3D, because only we can provide a consistent process chain from P&ID to piping to isometric. And we have the connection between the modules and, for example, also the automatic generation of the isometrics. Also very important for you is that we are, we already have long-term contracts with SolidWorks as well as with Siemens. So for SolidWorks, we have the highest partner status. We are gold partner, and with Siemens, we also have contracts for over 15 years now. And this ensures that we always support the latest versions of the CAD systems, and that we always provide the best support and the best possible user experience. Our headquarters is based in Munich in Germany for CAD Partner Europe. We have our development center in Prague with 20 developers. Then we've got our subsidiaries in the US as well as in Asia. And this is especially important if it comes to our larger customers, so that we can provide them a 24-hour support. So no matter where you use the software in the world, you can always contact us and you will receive the feedback and support instantly within a couple of hours. Coming to the software, it consists out of 3 modules. The first part and the start would be our P&ID tool. As I said before, based on the PC Schematic Automation. Then we've got the piping add-in for SolidWorks and Solid Edge. And the last part is the Smap3D Isometric based on ISOGEN. And the most important part is that all these modules are connected to each other. So if you define, for example, a tank or a vessel or even a pipe run in the P&ID, it will be also, you can also see this information. It will be transferred also to our piping tool, and in the end will also be visible in the isometric. You can also, the P&ID is also a standalone solution, so you can also decide only for the P&ID tool. If you don't do the process engineering yourself, you could also start directly with our piping tool. And if you don't need isometrics, for example, you can just use the piping as well. So there are different possibilities how to use Smap3D, dependent on your requirements in the end. The Smap3D P&ID part, as I said before, is based on PC Schematic. So you will see like it's the same look and feel. For example, also if you create data, like for example the parts lists, it's just the same like you know it from PC schematic. The administration of the database or the generation of the .pro, which are in both systems the same, is identical. And also, of course, it's important to know that, well, our Smap3D P&ID is for the process engineering, and therefore, of course, we have additional features and functions so that you really have a full P&ID tool. As I said, we have a database included as well, so it's available in different formats. Standard would be Access, but we also have, could also work with the MS SQL or Oracle, for example. We deliver more than 800 standard symbols within our library, and we've got different design and plausibility checks. So, for example, if you place an 80 pipe on a 100 nozzle, then the software will let you know, well, please check there is a mistake. Make sure that you have the same diameter on both. And as said before, very important for the P&ID part, that you can create all kind of reports and lists automatically at the very beginning of the project. This is where a lot of our customers have suffered before, because they had to do the lists manually with an Excel, for example. And of course, there are this is creating some mistakes, and maybe later on there are even wrong components on the building site, because in the beginning there had been changes in the P&ID later on, and the lists were wrong. So creation of reports and lists automatically out of the P&ID is a really important part for most of our customers. Our piping tool, the add-in for SolidWorks or Solid Edge, consists of out of the piping itself. Then we've got the piping library. Depending on the CAD system, you would either have 80,000 or even 120,000 standard parts included. And then we've also got our specific libraries that could be components that you design by yourself, or that could be supplier parts. If you need specific ones, then you can integrate them in the libraries and use them together with Smap3D. Very important part is that we have a connection between our P&ID and the 3D piping. As mentioned before, this works via our to-do list. So this list shows you in SolidWorks or Solid Edge what has been done in the P&ID, and you can work according to this, and you can make sure that you don't forget anything and that you're always on the same level like the process engineering. We are using pipe specs. It's really a must for the software, so it only works with pipe specs. Pipe specs have to be defined before as a standard, and then everybody in the company knows what to use. And we are only working with the 3D sketch. Then the pipe spec will be assigned to the sketch, and the rest will be done automatically by the software. As I said before, we are delivering 80 or even 120,000 3D piping standard parts within our software, and we also have advanced functionalities like the generation of insulations, reductions, and welding gaps, for example. We also do support non-round profiles, for example, cable trays or air ducts, and we can use all other native 3D CAD functions, either of SolidWorks or of Solid Edge. For example, the bomb creation, also with the correct cut lengths of the pipes. So this is because we are completely integrated in those CAD systems, and we only generate the native files. We can also use all other applications together from Solid Edge or SolidWorks. Last part is the isometric. They are automatically generated out of the 3D piping, so all the information are coming out of our Smap3D piping. We are based on ISOGEN, which is the market leader in the isometric drawing business, I would say. I think they have around 80% market share. So I think everybody who has to do with isometrics knows ISOGEN. And the display, the content, and the reports of the drawings of the Isometric is completely customizable. So there are thousands of possibilities how to do it. And this would be something that you could do together with our trainers to set up the individual isometric drawing that you need. And we have the output in DXF or PCF. PCF might be interesting as well if it comes to a piping simulation, stress analysis, so that we can export to, for example, Caesar 2 or RAW 2. All right, just an overview how Smap3D works and to show you the complete process. Also together with the ECAD of PCSCHEMATIC, of course. This can also be very beneficial for you because, as said before, it is the same user interface. Both are generating .pro files, so it's really easy to exchange data between the two and to make sure that your process engineering and your electrical department can share information. And this is a really good way because it's based on the same software. Then we have the 3D CAD, which is then SolidWorks or Solid Edge, whatever you prefer or you already have in your company. The piping add-in, as I said before, completely integrated. We only generate native SolidWorks and Solid Edge files. So you really have the mechanical engineering and the plant design within SolidWorks or Solid Edge. There is no separated solution for the piping or plant design. Everything happens in your 3D CAD together with Smap3D piping then. The last part is the Smap3D Isometric. As I said before, you can directly, just with a mouse click, you can generate the isometric drawings out of your 3D. Already mentioned before the PCF interface, where we can also go to the piping simulation. Because we only generate native SolidWorks Solid Edge files, we can use all other available add-ons for those CAD systems as well. For example, the CAD simulation tools of both systems. Also important part is the data management within PDM system, for example. So still, again, only native files, so everything can be managed with the standard PDM systems of both CAD systems. And we can also then have the connection to the ERP system, and then we have a real closed process chain. So from my point of view, we can talk a lot about features and functions, and we've got a lot of them, but this one is the most important part. So it's a really closed process chain. There are no separated solutions, and in the end, the most benefit you can get out of this closed and consistent process chain. Just the benefits in an overview. We have time savings to the complete solution and consistent solution from P&ID to piping to isometric. Our customers tell us about 30 to even 50% time savings, which they have achieved. We have to do less manual work, which will result in less errors, of course. So if you just think about the list generation, which we can do automatically in 2D as well as in the 3D. Also, the automatic creation of the isometrics can mean a lot of time savings in the end as well. Then we've got the pipe specs as a standard, and also to keep the expertise within the company. And we've got the 80 or even 120,000 standard parts for an easy and fast use of the software. Last part of my PowerPoint would be the references. Grundfos, the Danish pump manufacturer, is one of our customers. They are also doing pump systems, and they are using our complete process chain of P&ID piping and ISO for this. Then we've got Kaeser Kompressoren, a German company for compressors. They are our customers for far more than 10 years now, and they are using the software in many countries all over the world. And then we've also got Kaspar Schulz, which is the oldest brewery plant designer in the world. especially for them, it was really important to automatically generate the 2D lists directly at the start of the project, and they are even managed to be 3 times faster compared to their previous process. And the last one that I want to show to you is Planeta, which is a German engineering office. And I just want to show it to you because this is a really large glass fabric in Brazil. So it's more than 500 pipe runs and I think 10,000 square meter. So this is not our normal customer, I would say, but this is also possible with Smap3D and SolidWorks or Solid Edge as a CAD system. And also very interesting, Planeta is now also working together with us because they have a lot of experience in plant design for more than 15 years. And they have worked very long time with Smap also in projects. And they are now doing also training and consulting for our customers. And this is something they really like because they have actually the experience that they can transfer to our customers then. All right. That's it from my side. So I would head over to Michael to come to the more interesting part, I would say. So he can show you the software live.
Good. Thank you, Tim. All right, so again, my name's Michael Mooney. I'm the Technical Director for the Americas, and let's get into having some fun here. So as Tim said, looking at this, we were generally in a plant process engineering environment. Typically, you start with the P&ID. That is your controlling document. And so the workflow, if you do P&IDs, is you start with P&ID, and then that information is transferred over into SolidWorks through this to-do list. Okay. Now, while we're talking about the interfaces here, this is an important part to maybe expand on what that means to be a goal partner. Being a goal partner, there's no import-export and learning a whole new interface with a different program. It's all right within inside of your CAD environment, and in my case today it's SolidWorks. And so we get another tab up here in your command manager for piping, so all your piping functionalities right inside of here. If you prefer to pull down menus, we can go there as well. But the convenience of having these toolbars is really nice, as well as there's another tab here for the P&ID to-do list. Okay, that to-do list comes up over here on this side, and we can organize it to look at either components or break it down by pipeline. Okay, so we look at all the components. These are all the components that appear in our P&ID. So if we jump back over to our P&ID here, and I'm going to actually make my screen a little smaller here. Traditionally, I would just have maybe my P&ID on one monitor and maybe my my SolidWorks on another monitor. But for the sake of the presentation, I'll show it to you just kind of splitting my screen in half. Now the purpose here is to show that it's connected in real time. So it highlights when I click on something in P&ID, in the P&ID to-do list, it's going to highlight it in SolidWorks for me, and it's also going to highlight it in P&ID. So if you were not the person that created the P&ID, or were not the person that created the 3D models in SolidWorks, you can see how the two worlds fit together and see where this is represented in the 3D model and vice versa. This is very helpful if you have multiple departments doing different disciplines. All right, so also breaking this down here, we have another tab in the SolidWorks feature tree here, as far as one for piping. Now I've split my feature tree in half so that I can have less switching back and forth between tabs. So I can have my SolidWorks feature tree down here at the bottom, and I have my Smap piping tree up here on the top. All right. Also, if we wanted to come over here, we can look at things from a pipeline perspective. So I can come in here and I can drill down inside of a pipeline and then see the components that make up that pipeline and what they're connected to. So here I have a pump, and I can even break it down and see in the motors and the connections that it goes to if you want to drill down and find out more details right from the P&ID to-do list. All right. So let's jump over and go through a workflow process. I'm going to put a pump down here on the floor, and then we'll run some pipe to connect it and look at actually how we use the software in conjunction with P&ID and 3D modeling in SolidWorks or Solid Edge, and then we'll create a deliverable, which commonly is might have a requirement of a isometric or single line ISOGEN style of drawing. All right, now being our P&ID is a project-based system, so you'll notice down here at the bottom I have several different tabs. These tabs, similar to like Excel, where I can navigate between different chapters, different types of sheets. So I could have a cover sheet, a table of contents, different diagram sheets. Then we can get into different types of lists that we want to create, or reports. For example, like bills of materials. All right, so we got a bill of materials, and then we have a component list. All right, and so this contains the same drawing sheet information. It's just displayed in a different format, whereas a bill of materials is going to give you a single line item per an article number, and then a quantity of how many of those are going to be used. But a component list is going to break things down by the component name or the tag number. Okay, so that we can identify if we use 1400 millimeter globe valves, all from the same company. Each one of those globe valves is probably going to be controlling a different process, a different fluid medium, or something of that nature. So we can break it down and show exactly what page, what column, and what row it appears on. It also makes it very easy to navigate and find something where we can say, hey, where's this 4102 butterfly valve? I just click on it, and it navigates to that page, and it puts my mouse cursor on that physical component so that I don't even have to hunt for it on that page. So navigating from these report lists can be a very easy way to find the components that you're looking for, because quite often our customers might have, in some cases, hundreds of sheets in a P&ID project. Okay. Also, getting over into some other types of reports. It's quite common that people want to see, hey, I might be using some symbols that other people might not be so familiar with. And so we can have what we call a symbol legend, to where we can have a list or a legend of all of the symbols that are used in a project. Okay, and this is created automatically for us as well. So different ways that we can different types of documents that we can create and things of that nature. Now, one thing that we pride ourselves on is that we're working with an intelligent P&ID system. Now, what does that mean? Because for the past 15, 20 years, every software company on the planet has been calling their software smart or intelligent. And everybody has their own takeaway of what that actually means. In our case, what we mean by this is we are a P&ID or a schematic capture tool built from the ground up for these types of applications. We're not an architectural CAD tool that then we've just added a library of blocks that represent P&ID or electrical symbols. All right, so if we don't know what a symbol means, we hover our mouse over it, and it tells us exactly what it is. So there's more than just lines, arcs, and circles here. These are actually, components that have information about them. Also, if I want to know, hey, what size is this pipe right here? Oh, okay, that's an 80 millimeter. All right, and so all of this detailed information about what it is, who makes that component, what are the details, all exist. Also, being able to, very often, we can't fit everything onto one page. So we need to continue this onto another sheet. And that's where these line links right here, these arrows come into play, where it can actually navigate me and put my mouse cursor on where that pipeline continues on to another page. Okay, so again, if you're working with you know, a large plant with many different sheets, this can be very helpful of being able to navigate back and forth of where your design is carrying on to. Okay, and we'll talk some more about intelligence as we go along. So how do we actually use this? All right, well, we have a very standard you know, Windows interface here with you know, a ribbon toolbar up here at the top. These toolbars are completely customizable, so quite often our customers will go in here and they'll even build their own tabs in here of exactly what symbols and what components they most often use, so that they don't have to go in here and dig through the hundreds of symbols that we provide out of the box from what they want to use. Okay, it just helps streamline the process and going through there. All right. So if we wanted to come in here and do something like that, we might come up and we might say, hey, let's put in a piece of equipment, okay, or maybe a valve. And these valves might have many different configurations, if you will, or states that we could show them in, as far as just a regular normal, motor actuated, you know, diaphragm valves, all those different ways that we can show it. Instead of having to manage, you know, many more different symbols, we can have different versions, if you will. Okay, so I'm going to come in here, I'm going to drop in a pump, and then I'm going to create my pipeline to it, add some intelligence, and update my my reports. So if we wanted to go through the symbol menu, grab whichever symbol we want to use for a pump, we could do that. Or if you know exactly what component, okay, I know the manufacturer I want to use and those types of things, you can go right to that. But a lot of times you don't have that information just yet. You might come in here and say, hey, I want to put in a pump, right? So is it going to be a general pump? You know, what kind of pump are we working with? All right, and so we can drop it in here, and then we're prompted for, hey, we got information we need to put in here. Okay, so we need to give it a tag number. Now it's very important that we don't duplicate tag numbers. Okay, that could cause many different problems there. And we can state whether or not this is going to be inner equipment or not. I'm going to come back to this checkbox because it really doesn't do anything for us in the P&ID side. What it does is it affects the to-do list over here, and when we uncheck that box, we get a little blue dot on the component in the to-do list, and it places it at the top of the list. This is because that's a piece of main equipment, meaning that, hey, pipes connect to that, so I need to have that piece of equipment in place before I start running my piping. Okay. Otherwise, it's kind of hard in real life to connect a pipe in thin air, okay, and just have it float. All right, so that's what that little checkbox does. Now, at this case, I don't know, the engineering's not quite done yet to know what size pump I need and all of those details. So I can conceptually lay these things out and come back and add information later on. Okay, so I can come in here and I can say, hey, this is just a P3000. That's going to be my tag number, and I want to make sure I don't duplicate it. All right, so I'm going to hit my question mark. Has this been used? Okay, it has not because it didn't change. Now, if I did duplicate one and say, hey, you know, maybe I want to put in a P2002, which already exists. Okay, I hit my check mark or my question mark, and it rolls up to the 2004 because that's the next available free number in the numbering scheme. I'm going to go back to my 3000 here. All right, and we'll say okay. So now I have this in here. Okay, not a whole lot of information about it because we haven't told it exactly yet. And I can come in here and I can say, hey, let's just connect this all together, and we can draw these and connect them. Now, if you knew from the very beginning exactly what sim or what component you wanted to use, you could go right into your component database, right? and you could say, hey, I want to put in a pump from Grundfos, for example. Okay, and so we can come in here and we got pumps, we got all kinds of them, different categories that we could put in here. But I'm looking for maybe a specific manufacturer. So I could come in here and say, hey, let's search out here for all of my components. And as I start typing in something, I could choose any one of these pieces of intelligent data about the pump. And so I could say, I'm looking for a manufacturer, Grundfos. So I start typing in G, and it starts filtering out everything that doesn't meet that criteria. And so then I'll find exactly the one that I want to use, and we can see some previews of them and those types of things as well. And then I can say, okay, that's the one I want, and it goes and automatically retrieves the correct symbol that's supposed to be used for that particular pump. Okay, and again, I'll come in here, put in my information, and then if we wanted to put more specific user or use case, if you will, information about, hey, what fluid medium is actually being used in this particular pump for this particular application or process. So all this information can be shown here, and we'll say okay to that. Now, as we go through and say to this, if we hover over it now, we have that information about it. So more and more information is now visible that we have a component. Okay. And again, it's important also to know that kind of back to that whole built for schematic capture, if we try to draw a pipeline that doesn't connect to something, notice these little red diamond shapes. These indicate connection points. If I try to draw a pipeline that's not on a connection point, it flags me and says, hey, are you sure you want to put a piece of pipe out in the middle of nowhere? And I can park it there. In my case, I just mispicked, and so I can come back here, and once you actually do get it on a connection point, they connect and they stay connected. Okay, so we can move things around. Now I need to give it information about the pipe. So I could just double click on it, and I can say, well, I can't remember what tag numbers I've been using here. So I can pull up this list here and find out all the tag numbers that have been used for pipes in this particular project. And again, if I was to duplicate a tag number, I can tell it to count up to the next one so that I don't duplicate those if I didn't want to. There are certain situations where you would want to do that if you were creating like a loop drawing or detail view, something like that. All right, so I'm just going to give this a PL300. What information do I want to be visible on the drawing sheet? All right, so when it comes to size and article number and spec, I could type all that in, but that's error prone. So I'm going to pull up my pipe specs here, and now my pipe specs are going to tell me what is available, what I'm allowed to be using here per the pipe specs. So it's got different sizes that are available, all kinds of different options here as well. And notice that they don't even have to be round pipes. We could do HVAC ducting, cable trays, any shape of profile that we want to create that with. So I'm going to go with a 100mm piece of pipe here for my pipe spec 10CA, and I'm going to tell it that I want the tag number and the size to be visible on the drawing. Also remember that these, I could say that this is going to be steam, maybe, all right? And what the operating temperature is going to be, right? And all this information can go in here, and then that information will be available either through a report or right there available. See, we'll second from the bottom is steam, the operating temperature. And so that's another thing what we talk about with intelligence. Now, expanding on the capability and the power of pipe specs. So far, pipe specs have just kind of limited how much information we have to type in, but they can also limit what types of equipment you're allowed to put into a pipeline. So instead of coming over here to the pipe component database and finding a valve, I want to put in maybe a globe valve in here. So I can come in here and we can just say, hey, let's get everything, and anything that we go in here and basically with this, we could put any valve that we want into this pipeline, and any size valve that we want into this pipeline. And that could be error prone if we put the wrong thing in there. So we don't want to put a low pressure rated valve into a high pressure pipeline. Okay, that's the way that you either cost a lot of money or potentially get somebody hurt or killed. So if we right click on the pipeline, we can place equipment from the specification. So our pipe specification is telling us, hey, you're only approved to put these 4 pieces of equipment into this spec and this size of pipe. All right, so this really takes that that headache off of the designer's shoulders of having to know exactly what pieces of equipment are allowed to be put into this particular pipe spec and this size of pipe. So I'm going to go with this globe valve here. All right, and so then we can come in and I'll just place this right down here on the nozzle and then we can give it some information here. We'll just say that this is going to be maybe my V3000. And then I'm going to check, has this been used? Nope, it has not. I'm going to leave this checked this time, and when we get back over into the to-do list in SolidWorks, you'll see how they've come across. So we'll say okay to that. We get our component in here. And again, if I go back into this component, I forgot to show you, we got a little JPEG picture of what it looks like in real life, but we can also include manufacturing information. So we don't manufacture this, we actually buy them and put them in our product. Okay, so if we needed more information about this, we don't have to you know, blow the dust off the 3-ring binder on your in your office there of the manufacturer's catalog. We can actually just download it right from their website and then add it to our database so that it's right there linked in, and anytime a designer needs it, it's right at their fingertips for any of these components that we want to include that information. So another level of intelligence here, really saving time of finding you know, these spec sheets from the manufacturers. So very handy tool right there as well. All right, so I got everything in here. This looks nice. We can also get in, add insulation if we wanted to. Just by right clicking, boom, got insulation. This all looks good now. And let's go ahead and update our component list. So if we go here to our component list number 2 here, all right, we can see it here. We got 30 items. If I come up and update all my lists, now we're going to get in here and we'll see that, hey, I've got some new components. I have my P300 3000 here. There's my pump. If I double click on it, again, it takes me back and puts that in there. Also with bill of materials, that updates as well. Now I have 2 of them instead of just 1. More valves, all of that good stuff. Now these lists can also be exported out to an external file, okay? Any of these lists that get created. So I can choose what information is going to be in there, and then I can choose the format that I want. Do I want it to be a CSV, a text file, an Excel spreadsheet, even what version of Excel do we want it to be? Or even an XML file if you want to try to connect it to another system, okay? So those are all easy ways to export these. Speaking of exporting, let's say that I need to communicate this information with somebody else, either inside of my company or maybe a vendor or a customer that doesn't have access to a license of Smap3D P&ID. So what are we going to do there? Well, first thing people would think of is, hey, we can export it to a DWG or a DXF. However, that still requires that person to have something that can read those types of files. I don't know many people or hardly anybody that does not have a PDF reader on their machine these days. So we actually have a PDF export, and we can control what pages we want to export. We can control where it goes and what resolution and all of that good stuff. We can also control what information we want to be shared with them, because we might be putting in our P&ID internally, we might be putting proprietary information that we don't want to get outside of our company. So we can turn that on or off. And then we can come over here, update all of our lists to make sure everything's there, and we can just export all of this out. So now you'll notice that I'm in Adobe Reader up here, okay, which is the one that I prefer to use. And we have a 12-page PDF here, so my entire project is built in, and as well as the intelligence. Okay, so what we've really done is we've taken the basically embedded our viewer into the PDF. Okay, so we have a free viewer, but that requires permissions to be able to download and install software, which often we don't have from IT these days. So all of these are here and available. We can also come in and let's just get this full screen. All of our links work to where we can navigate back and forth between different pages, as well as the intelligence in our reports here. Okay, so you want to find your components. Boom, there's my V2001. Okay, and so this is a great collaboration tool to be able to communicate your designs with other people that don't have access to a license of Smap3D P&ID. Now, how does all of this information get back to SolidWorks or Solid Edge in the 3D world? Because as you notice, we don't get cut links in here. We don't know how many elbows and flanges are needed inside of a P&ID because we don't know how it's going to travel from point A to point B. So that's where the 3D world is critical. So we're going to come up, and our synchronization is semi-automatic. We invoke a refresh to resynchronize the P&ID to the 3D, and it's checking to see, are there anything in the P&ID that is not in SolidWorks? All right, and it comes up and it says, hey, this E2001 is out of date. Okay, you don't have to remember that because we're going to put a symbol on it over here in the to-do list. We're going to flag it for you so that you don't forget that. And then it comes already highlighted here. And we'll notice there's some more information here. So there's a new pipeline used in Spec 10CA, and it's 100 millimeters. All right, so I'm just going to update all my connections there. And so now it knows all the connections that are being used. Okay, we got that new one that just came in with that valve. Also, my list, you'll see that I did not put the checkbox. I forgot to check that off. So it did not put a blue dot on there, but if I just come back over here and refresh this again, we'll see that this will pop in. And then we can go through and create our pipeline. Now it's very simple in the fact that we work with all versions of SolidWorks. Okay, we don't use any technology from SolidWorks routing or from Solid Edge routing. We have our own piping engine, so we work with any version of SolidWorks, standard, professional, or premium. All right, and I'm going to come in here and I'm going to say, all right, well, here's my pump. I know I need to place that in there, so I'm just going to right-click and say, place the fitting into CAD. Now, in this case, it's not a standard pump that I use, so I can come out here and I can actually browse my whole database and find out what pump I want to use. Okay, so this opens up the Smap3D piping part library, or we can come in here and look at the different components, the different sizes that we might have. And in this case, I got my pump. Let's go ahead and place this into my assembly. So we'll say, go ahead and select that. It loads it up into the SolidWorks insert component command. And then we can even leverage the mate references or smart mates to pop things right into position. Okay, so we're just doing native SolidWorks commands right now, inserting a component into an assembly. And then it checks it off over here, and now it knows exactly where that goes. Now, I've chosen to also integrate my other components, like my accessories here, my motor, so I can assign that to this component as well, just by clicking on it in the graphics area. So now those are all checked off there. Now if I go further down my list here, now I'll notice that I got a valve, okay, and it does not have a blue dot on it because it's an inline component. I can also view things again by the pipeline. So let's come over here and look at my pipeline. I know that I need to create this PL300 here, but I don't know where it goes from and to. The heat exchanger up here is a little easier because there's only one nozzle that hasn't been used yet. But what if it was the first pipe off of this heat exchanger? How do I know which nozzle? Or more importantly in this case, how do I know which nozzle of my pump this is going to go to? So all we need to do here is right click on it in the to-do list and tell it to show the from to points. It's going to come out here and it's going to put red dots on the nozzles that are used for this pipeline. So now I know where I'm going from and to. I can hide those, get them out of my way. And it's also very helpful to organize your assembly as far as all your pipes into sub-assemblies, okay? It's not required, it's just a very nice organizational tool to use that SMAP is going to help you with by right-clicking and saying create an assembly in CAD. So it creates your a sub-assembly and it automatically names it to match the tag number from P&ID. So maintaining that connectivity. And so we'll just come in here and we'll edit this in context of our assembly. All right, and we'll also point out that this is a empty blank assembly. There's nothing in it at all, okay? And so as we keep going along here, we'll find that, that SMAP is gonna be automatically creating things for me as I go. So I know where I'm going from and to. We have our toolbar organized so that you don't have to remember these steps. You can just come up here and say, okay, well, here's my order of process to use piping. I create a subassembly if you choose to. Okay, so I've already done that. Then I create a piping 3D sketch. Then I turn that sketch into a path. Then I generate my pipelines. And then I have the tools to edit the pipes after I've created them. All right, so let's go to that second step. I'm going to create a piping 3D sketch. Now this is the same exact tool that we use for the SOLIDWORKS 3D sketch. The only difference here is that we name it Piping 1 instead of 3D Sketch 1. Okay, that way our piping engine knows that that 3D sketch is supposed to be used for piping as opposed to maybe another 3D sketch that's going to be used for weldments or for a skeleton layout sketch, whatever you might use them for. All right, and so here we can just use the normal line tool if you wish to have full control over exactly when it's going to, you know, make a bend. Or if it's something very simple and orthogonal, I can come in here and I can say, hey, I want to go from this nozzle down over here to this nozzle. Okay, and then it draws a 3D sketch for you. And then you can have some control over this as well. And I can say, you know what, I want it to go straight down before it turns and creates a bend. So we can do that. You can also, you know, move this around a little bit, get it where you want it to go, and then say okay, and it turns it basically into a 3D sketch for you. All right, now you can come in now and add a dimension here to fully define this if you wish. I'm going to leave it underdefined, and this is going to allow me some flexibility if I need to move things around later on to avoid collisions or clashes. But I'm happy with that 3D sketch right there. I'm going to say that that's fine. And then let's go back over here to my piping toolbar, and we'll go to the next option here, or the next button, which is to turn that into a path. So now it's identified as a path for piping. And we can come over here and say, well, I'm ready to turn this into a pipeline, okay? Now, if you're not using P&ID, then you would click on this button here. But since I'm using P&ID, and I've already defined that in my P&ID, I'm just gonna come over and I'm gonna say assign the pipeline. Well, so take all that information that I put into my P&ID and assign it to this path. All right, excuse me. And it comes in and says, okay, now all the information has been assigned, it knows what it's supposed to be, and it starts building the assembly for me. okay? And so it's looking at my pipe spec, and it knows that I need to use this type of pipe, and it needs to be, you know, butt welded, and we need to have 3 millimeter weld gaps, and also I need to be using welding neck flanges, and also this requires a gasket in here. So it's put a flange and a gasket on there, trimmed the pipe back to accommodate for the welding gap, as well as all of the weld gaps for all the other fittings as well. All right, so the system has built our pipeline for us. If we look over here in our SOLIDWORKS feature tree now, I have a bunch of parts in here, and I have a bunch of mates that's been created. And this is also important because if you need to share this subassembly or overall assembly even with somebody else that doesn't have SMAP, they won't know that you use SMAP. They'll just think that you've done a lot of work, okay? So you can share this data with other people that don't have SMAP. They just won't be able to edit it and come in here and make a change as far as to change the different size or something like that. We're not done yet. We don't have everything checked off. Notice up at the top, we still have a warning sign here. We got the valve, so we can choose where we want to place the valve in. And for that, we just need to right click and say place the fitting into CAD. And then we can come over here and just drop this right where it's supposed to go. So again, with mate references, this makes it very easy to go in and drop it right on where it's typically supposed to be mated. And so we can put these things in. We can also create, you know, mates down here to say, hey, I want to be, you know, a certain distance off of the floor here. Okay, so I want to make sure that people can reach this to do, you know, the operations. So we'll make it 1 meter off of the floor. All right, and we'll say we're happy with that. And then the component gets assigned. So it's going to turn green here. And then I just need to finish it off with a recalculate. Okay, I can either right click, I'm a big right clicker, or you can go to the toolbar up here and tell it to recalculate that pipeline. That's going to cut this piece of pipe and also make sure that any supporting components, such as flanges and gaskets in this case, are inserted, and then also the pipeline is trimmed back to accommodate those properly. All right. Another thing that could happen is maybe I want to come in here and generate insulation. I insulated it on the P&ID, so I can come over here and I can say, hey, let's generate my insulation here. And it'll come in and automatically generate all of this insulation here for me, and I don't even have to worry about it. Okay, and so this is a great tool to go in and do all of that. It even knew not to put insulation over the valve. Okay, all part of our pipe spec and how our pipe spec governs the way that pipes are built, so that you can do it exactly the way that you guys are supposed to be doing it per your process. Now, finally, creating drawings. Okay, it might be 2018, but we still have to create drawings. So you can use the SOLIDWORKS drawing tool. Okay, that works just fine. Native SOLIDWORKS parts and assemblies or Solid Edge. But SOLIDWORKS and Solid Edge cannot generate ISOGEN drawings or single line isometric drawings. So that's where our isometric tool comes into play. We can come up here and it's literally 2 button clicks, start ISO, finish ISO, and it's going to go in and it's going to take it, it's going to convert all the line work, it's going to convert all the valves and the equipment to the proper symbols, and it's going to go in and generate all this for me so that I don't have to do this. And we have customers, if you were to run this from the top level assembly, it would batch generate all of your pipe spools as well. So we have some customers that they're like, well, it might take about 12 to 15 minutes, but at the end of that, you know, I got 200 drawings made, which typically it's going to take me about an hour for each drawing if I had to create that myself. Okay, so that can be a tremendous amount of time savings there. We have different templates that can be set up to be used here, and in this case, I just have a basic drawing here. And so I have this chosen to do this in a DXF format because it's widely accepted with the people that I'm going to be communicating this with. But important things that come in here, like northings and eastings and the elevation of this connection, are automatically put in here, as well as the dimensions and how these go across. And so all of this can be very helpful, as well as what style of dimensions do you want. Also, do you want these bill of materials broken out into two different lists, a fabrication list and then an erection list? Also, I can see that I got 3.8 linear meters of 100 millimeter pipe. I got 3 elbows, 4 flanges, and then we get down in here to the erection as far as the gaskets. And also point out that I know I need 64 washers and 32 nuts and bolts. I did not put those into my SOLIDWORKS assembly. However, the information is there, and our SMAP Isometric is intelligent enough to be able to put that information right into the bill of materials there. So saving some system resources by not cluttering your RAM up with thousands of fasteners, and then all of the information that we want to be put in here. So many different templates can be set up. I'm going to take a look here at my results here, and if I was to have come in and let's just say that I put in from the top level, I ran this, every different style of drawing. For example, if you wanted to do like a spool drawing for these, you could come in and see those as well. Again, different styles of dimensioning. This is going to go flange to flange and automatically break it out. And then in this case, we've chosen to put a weld list and a cutting list in here. Okay, so it just depends on what information you want available. And so our weld list, cut list, those types of things are available very easily right within inside of our ISO tool. Okay, now cut lists we can get in a standard SOLIDWORKS bill of materials, but these weld summaries are something that's unique to ISO. Okay, and so that's really our whole close process there. With that, we were able to go from P&ID, create our process documentation there, or piping and instrumentation diagram, share that information, import it right over into SOLIDWORKS to do all of that, and do the 3D so that we know all of the cut lists and what we need. Is it going to fit? Are we interfering with other components? If that's the case, we can come in here and we can move things around, and boom, they update. And then we would just need to regenerate an ISO for all of the correct cut links. All right, and so the beauty of working with that is we have everything in one format as far as with SOLIDWORKS, except for the P&ID. That's its own environment. And it works with whatever data management system that you're using today for your SOLIDWORKS or Solid Edge. All right, and so with that, we have some questions, and if Tim has anything to add that I forgot, I'll give that opportunity as well.
No, I think you did a good job, so nothing to add from my side.
Excellent.
So I think because we are, perfectly on time, but nearly done now with time, I would say if you have any questions, please send them to Kirsten or to the email address that will be forwarded to you in the next mail that you will receive. And of course, we will then get back to you and answer your questions.
Yeah. And just in case, here's a webinar at PCSCHEMATIC.com.
Exactly. So you could address your questions and send it to this email address, and we will get back to you as soon as possible.
All right. Thank you all for joining, and have a fantastic afternoon.
Thanks for joining in. Bye-bye.
Bye-bye, everybody, and thank you. Yeah.
Thank you too, Kirsten. Bye-bye.
Bye.